Hello and welcome to AP Physics 1 Crash Course. We are on Unit 3 Work, Power and Energy, and this is the second topic, which is kinetic and potential energy. In this we are going to talk about the energy. So first is our kinetic energy. Kinetic energy is due to its motion because of its speed it possesses. So if any object having mass m and moving with the speed v, the kinetic energy is given as half mv square. So kinetic energy is equal to half mv square. The SI unit of it is joule. Let's see some of the examples of kinetic energy like meteoroid, walking, falling, throwing a ball. So the velocity of the ball, the ball would have kinetic energy. A flying airplane, so it would have kinetic energy. So whenever there is a motion, the kinetic energy is associated with it. An object falls from the height of 15 meters above the ground. After striking the ground, it loses 40% of its kinetic energy. The height up to which the ball can rebound from the ground is. So, a ball is initially falls, so initial velocity is 0. It covers 15-meter distance, so G is acting in the same direction. Before hitting the ground, it has the velocity V1. After hitting the ground, the ball loses 40% of its kinetic energy, and with 60% of the kinetic energy, it would rebound and come back with the velocity v2. So with v2 velocity, how much it gained the height when it rebounds back? Before the final velocity is 0, what height it would cover, we have to find it. So to find v1, we have to use third equation of motion. We have to use third equation of motion, which says that final velocity square is equal to initial velocity square plus 2as. So final velocity v1 square, initial is 0, and plus 2a in this is the g, which is 10, and s is the displacement, which is 15 meters. So in this case it would be 300 root of v. This is the v1, root of 300 meter per second. Kinetic energy at point 2 is equal to 60% of the initial kinetic energy, because 40% is lost in the collision between the ball and the ground, and when it rebounds it has only 60% of the initial kinetic energy. So I can write half m v2 square would be equal to 60 upon 100 into half m v1 square. Half got cancelled and m got cancelled. So v2 would be equal to, or v2 square, 6 upon 10 into 300. This got cancelled. It would be 180. So v2 is equal to root of 180 meter per second. This is the velocity. So to find the h, we again can use the third equation of motion, which is v square is equal to u square plus 2as. In this case, the final velocity is 0 and the initial velocity is root of 180 square of it, and plus 2a. Acceleration in this case is in the this direction, downward direction, and the motion is in upward direction. So they are opposite, and that's why negative 10 minus g is minus 10 in this case, and h we have to find out. So it would be 180 is equal to 220 into h, 0 got cancelled, and h is equal to 9 meter. A is your correct option. Next topic is gravitational potential energy. Potential energy of a body is due to the height from the earth's surface. If a body has a mass m and it is at height h, then the potential energy of that body would be equal to mgh. The unit of gravitational potential energy is joule. A planet, a moon and a star are aligned as shown. The moon has mass mm and is the distance r from the center of the planet. The planet has the mass of mp and is the distance capital D from the center of the star, and whose mass is ms. The derive the expression for the total gravitational potential energy of this three body system. The potential energy of this system would be equal to potential energy of planet and moon plus potential energy of moon and star plus potential energy of planet and star. Potential energy is equal to minus G m1 m2 upon R. So this potential energy and the one we read in the previous slide, which is mgh, is the same. It's just that that is the specific case for the earth, and we can derive the same from this equation as well. So potential energy is equal to minus G m1 m2 upon the distance between them. So UP means the potential energy between planet and the moon is minus G mass of the planet into mass of the moon divided by the distance between them is small r. Potential energy between moon and the star is minus G mm up into ms upon d minus r, which is the distance between them. And the potential energy between planet and star is equal to minus G ms into mp divided by the distance between them, which is capital D. Just put all these equations. This is equation 1, this is equation 2, this is equation 3, and this is equation 4. So put 2, 3 and 4 in equation 1. So the U of the system is equal to minus G mp into mm divided by R minus gmm into ms divided by d minus r minus gms into mp divided by capital D. So this is the potential energy of this whole system. Next is elastic potential energy. So when on a spring, when we apply force, either we compress it or we stretch it. The work is being done on the spring. That work is being stored as a energy in the spring. That we call as elastic potential energy. So when there is no force acting on the spring, then that is length is known as unstrained length. Unstrained length. And x is the change from the unstrained length, like how much stretching or compression is there. That is known as x. So elastic potential energy is equal to half k x square. K is the spring constant. The unit is joule. Let's solve this numerical. The potential energy of a long spring when stretched by 2 cm is capital U. If the spring is stretched by 8 cm, the potential energy stored in it would be. So U is equal to half k x square. X in this case is 2 cm. And when the stretching in the spring is by 8 cm, then the potential energy is denoted by U dash. It would be half k 8 upon 100 square. So let's divide U dash upon U would be equal to, the ratio would be equal to 1 upon 2 k 8 upon 100 square divided by half k 2 upon 100 square. So it would be 8 into 8 divided by 2 into 2. So it would be 4 into 2, it would be 16. So U dash is equal to 16 times of U. D is the correct option. That's all from my side. If you have any query related to the video, then you can scan this, directly message me. If you want any private tuition from me, then you can mail me on foster.physics@gmail.com or directly message me on the LinkedIn. The link is provided in the description. See you in the next video.